Okay, who wants to try this one? This also tells me that you did your homework yesterday. Hey, not everybody at once. Alright, Aaron.
So we do plus A on the right equal sign.
Yeah.
So that is negative 3x equal to things.
Uh-huh.
Then we divide by 3.
By 3? You divide by -3. Right. Okay, so I just wrote this out yesterday with the inverse operation. So like if I were to just explain this equation, it would be x times -3 minus 8 equals 10. So then in the inverse operation, then this will be plus 8. And you can see you divide by -3. If you just divide by 3, you did double opposite. Right? Because this is times -3. So the opposite is just divide -3. Right? And so if you do that math, you will get the answer. -6. Good job. Okay. How can I know I got perfect on the test before I submit? Tessie? How can I check?
Plug -6 into x. -6 times -3 is 18. 18 minus 8 is 10.
Perfect. Right. So always check your answer. You can know that you got perfect before you submit. Okay. So for the same reasoning, let's say this one. So you have x times 4 divided by 5 plus 1 to give you -3. So inverse operation tells you to -1 times 5 divide 4. And if you do that on the calculator, this morning the other class did this on their calculator, but it gave them the wrong answer. Okay, that's because they didn't have the brackets. Okay, if you don't have the bracket, your calculator will do the -1 times 5 before it subtracts. And in this order, we know that we want to do the subtract first. So you can either put the bracket in or press equal sign and then times 5 divided by 4. What do you get for your answer? Aiden, -3 minus 1
-4
times 5
-20
divided by 4.
5 -5.
-5. Okay, and then sub it in. 4 times -5, -20 divided by 5, -4 plus 1, you get -3. So there's my check. Okay, so this was yesterday's homework. We're gonna build on this today. We're gonna build on that. So page 11 of your booklet. Page 11. Okay, so I have a scale right here, a balance. I have a balance. I have 4 blocks right here. What can I use to represent 4 blocks? Tenzi? 4 blocks.
4x.
4x, right, okay, or 4n, because I don't like to write the x because it looks like the multiplication sign. And then here, each one of these balls is 1 gram. So since gram is just a unit, I'm not going to include it in my equation. So it's just +6. Okay. And since notice this, the balance is equal, it's equal on both sides. What is on the right side then? 7n. Good. Okay. So what's the difference between this equation and these equations that we did yesterday? What's the difference? Yeah. There are 2 variables on both sides. There's 1 variable, but it's on both sides, right? Because it's the same variable. So when you have variables on both sides, what you want to do is the following steps. You can move all the variables to the left and move all the numbers to the right. But if I just throw 7 blocks over to the other side, it's not going to make it balanced, right? So don't forget to change signs when you do this. When you put the blocks over, you have to do the opposite. So 7n, opposite of 7n, negative 7n. Opposite of 6, minus 6. Right? So don't forget to change signs. Next, before the break, we know how to collect like terms. What is 4n minus 7n? Lexi? Huh? Sorry. 4n minus 7n?
Sorry, wait, no, sorry. I'm, sorry, I was not focusing.
That's okay. 4 minus 7.
Sorry,
Negative 3 what? N. That's right. Okay, so negative 3n equals negative 6. And then the last step that you want to do is just to simply divide. So, Kai, negative 6 divided by negative 3?
2.
2. Yeah, that's it. And that's your answer. Okay. So if now I want to check, I can substitute back in here. So I'm saying that each of these blocks is 2. 2, 4, 6, 8, 9, 10, 11, 12, 13, 14. So I get 14 on the left side. 2, 4, 6, 8, 10, 12, 14. I get 14 on the right side. And so they are balanced, and I know that this is my answer. Okay? So whenever you have variables on both sides, you want to do these 3 steps. Now, do I have to move all my variables to the left? Is it only the left side? No. Okay, as long as you separate the numbers and the variables on 2 separate sides, it doesn't matter if it's really the left or the right. Okay, so this example 1 right here, let's try this one then. Okay, what do I move to the left? What do I move to the right? Phil?
So you can move 4x to the left, and you can move 2, like, so you subtract 2 from the right, so you get 2x is equal to 8.
Yep.
And then you divide by 2, so you get x is equal to 4.
Perfect. And then you just divide, and so you get x equals 4. Okay. Check my answer. So, Simon, 6 times 4 plus 2? 26. What is 10 plus 4 times 4? 26. So left side equals right side. Checked my answer. So I know that my answer is correct. X does equal 4. So again, it's very important to check your answer. Okay. Example 2, now with the negative signs. So same idea, but with some negatives. Richard, what should I move to the left side? Okay, I want to move all my variables to the left. So which one of these terms should I move to the left? Oh, and when I say left or right, I meant like to the equal sign. So this is left of the equal sign, and this is right of the equal sign. So I want to move that 2c over, right? I want to move the 2. Well, I want to separate it like, so the easiest way to separate it is to move all the variables to the left, and then move all the numbers to the right. Okay. When I move it though, what do I have to do with the sign? So instead of positive 2c, it will become negative, right? Okay, so negative 3c minus 2c, and when I move that 7 over, it's negative 7 minus 8. Now notice right here, I put the 2c behind, but then here, the 7 I put in the front. Does the order matter? Fujesia? Does the order of how I write these matter? So, yeah, so negative 7 minus 8 is the same as negative 8 minus 7, right? Yeah, so order doesn't matter, but what matters is the sign. So if this is negative 8, make sure you have negative 8. If this is negative 2c, make sure it's negative 2c. So the sign matters, but the order doesn't. Okay. So, Megan, what is negative 3c minus 2c?
Negative 5C.
Good. And then negative 7 minus 8? Good.
And then divide by negative 5 to get C equals to 3.
Perfect. Okay. And then do my left side, right side check. So, Joanna, negative 3 times 3? Negative 9 plus 7? Negative 2. Okay, what about on the right side? 2 times 3 minus 8? Negative 2. So left side does equal the right side. I know that C equals 3. Oh, and when you do the substitution, make sure you're substituting it back into the original equation, not the second step or the third step. Right? Original question, that's how you know it's correct. Okay. This one. Example 3. What makes example 3 look hard? The fractions. Do we like fractions? No, we hate fractions. Okay, so here's a little trick for my students. Okay, so this is what I always do. Whenever I see fractions in an equation, I just multiply everything by the lowest common denominator. Okay, so you want this will like it's a little trick that always works when it's an equation. You can't do that for expressions, but you can do that for equations because you're doing the same thing on both sides. So right here, 122 divided by r equals 3. What is my denominator here? Yep, r. So I'm going to just multiply all of my terms by r. So 122 times r divided by r, what do I get? Yeah, 122. Yeah, that's right. And then 3 times r? 3r. Right, so now this ugly looking fractions suddenly became a nice simple equation like this. Right? So I multiplied each of the terms by r. So 122 times r divided by r is just 122. And then 3 times r is just 3r. So how do I solve for r now? Yep. Yeah, that's all. 122 divided by 3. Since it doesn't go in evenly, I can just write it as a improper fraction. Or if you're really good, you could write it as 40 and 2/3. But you could just leave it as an improper fraction if you want. Okay. So for 3b, what's my LCD here? I have a 3 and a 5, so my lowest common denominator, 15. So I multiply each of my terms by 15. Not just to the left side, not just to the 7, but everything. Right? Think of the scale. You have to balance both sides. Otherwise, you changed up the whole equation. So let's see. Edward, what is 2 times 15? 30 divided by 3? 10. Yeah, so 10n. Right? 4 times 15? 60 divided by 5? Yep, so 12n. Right? And then 7 times 15, that one is a hard one. 105. Good job. So you see, one simple step, no more denominators. And it looks much nicer and much more friendlier. Right? So, Noel, can you help me finish up this question? What should I move to the left? The 12n, right? So when I move it, it becomes minus 12n. And then? Yep. And then my last step is to divide by -2. Again, a common mistake that people do is they divide by 2. They're thinking they have to do the opposite. But when you are dividing, you're already doing the opposite. Right? So that's why you keep it as -2. And so that's your answer. Or if you want, you could be fancy and write -55.5. Okay. How are we doing so far? Good. Okay. So this is a very powerful trick. Okay. You can always do this for in equations. Okay. If I have okay, if I have something like this, can I do this trick? If I have this, can I use this trick, multiply everything by the lowest common denominator? Will it help this situation, Simon?
Good.
I could, but then I'm just making all my fractions bigger. It won't eliminate my fractions because it's not an equation. You can only do this trick if it's an equation, because otherwise it doesn't help. Okay, so just keep that in mind. Okay, so only if it's an equation that this will help get rid of your denominators. Otherwise, you can't just take it away. Okay. Example 4 on page 12. This is a tricky problem. So pay attention to this. Okay. Page 12, example 4. A cell phone company offers two plans. Plan A, you get 120 free minutes, and then each additional minute is 75 cents. Plan B is 30 minutes free, and then each additional minute is 25 cents. Okay. So for the plan A, can we write an expression? Can we write an expression to model A? Let's see. Aiden.
T minus 120 times 0.75.
Good job. Okay, but what about that T minus 120? What do you need to put it in? So he said T minus 120 times 0.7. Yeah, you have to put a bracket around this. Okay. Why is that? My first instinct would be just do 0.75t plus 120. But what's wrong with that? Right? If you did this, all right. So this is a common mistake that people will do. Okay, they might write something like this. But what does that 120 represent?
In the equation, you're adding it as like money, not like time.
Yeah, exactly. This 120 is time. It's not cost. So if you write it like this, you're saying the cost is 120 extra. So the time you so it's part of time. So that's why it's t minus 120. Why are we subtracting the 120?
Free time.
Yeah, because it's free. The 75 cents is additional. So however much extra you talk, that's when you get charged. So if that's the case, then what's plan B? How will we set up plan B?
T minus 30 times 0.25.
Yeah, T minus 30, and then times a quarter for each extra minute. Right? And then for which cause will it result in the same cost for both? So same cost meaning that it's an equal sign. So when I model it, it's going to be like this. All right. Don't forget the distributive property. We learned that before the March break. So 0.75, I have to multiply it to everything inside the bracket. So I get 0.75t. 0.75 times negative 120 gives you the negative 90. So this morning's class was asking, where did this negative 90 come from? Because you multiplied.
And just divide each side by 0.25, then you got.
Yeah, you could. Yeah. Yeah, both way works. Okay, and then now this equation is just like example 2 that we did. So we want to move the 0.25 over. So 0.75t minus 0.25t, you get 0.5t. Move that 90 over, and you get 82.5. So when you divide it, you get 165. Don't forget your unit in this case is minutes. Okay, not dollars. Okay, it's 165 minutes. Okay, so how do I do the check? How do I do the check in this case? Input it where? For t. So back to the original statement. So if you just think logically, even if you got this equation wrong, think logically. You're saying that when both plan, you talk $165, they are the same, you get charged the same. So if you think logically, well, $165, I get 120 minutes free. So that means I have to just pay for 45 extra minutes, 75 each. So I get charged $33.75. Whereas plan B, if I talk 165 minutes, I only get 30 minutes free. That means I'm paying 135 minutes, but it's cheaper. It's only a quarter each. And when I do the calculation, it's still 33.75. So it's correct. I know my answer is right. It's 165 minutes. All right. If you did this, let's say you did this, what will end up happening is you'll get t equals a negative number. Okay. Is that possible? No. Okay. So you know that time cannot be negative, and they're not paying you back if you don't use the phone. Okay. So a lot of ways for you to check your mistakes if for this chapter with algebra. Okay, last example. So this one is a little tricky, but I know you guys can do it. Okay. Last example right here. Okay, I have this nice T-shirt that I want to buy. Okay. Sale price is $41.49, and it was on sale for 17% off. What is the original price? Doesn't this question seem familiar? Yeah, we did this in chapter 1. So in chapter 1, we were actually doing algebra before you know it. Okay. So now that we know all the skills, let's revisit this question and see if you can do it easily. If it's a sale of 17%, what does that mean? How much are you paying? Yeah.
83% of the original price.
Exactly. Good. And you just told me the next step. 83% of the original price equals 41.49. Can I rewrite this with just numbers? Yep.
8 times 0.83.
Okay, so 83%, I need to change that to a decimal first.
Yeah, yes. 0.83.
Yes. Oh, sorry, I missed that. Yeah, so 0.83 n equals this. And so my last step is just simply, what do I do as my last step? Casey?
Divide 49 by 2.
Yeah, just divide it. When I divide it, I get this as my answer. Let's grab my calculator. 41.49 divided by 0.83. I get this. So what's my final answer here? How much is that sweater? From
$49.99.
$49.99. If you say $50, I'm gonna take half a mark off. Sorry, I'm not being mean, but money always 2 decimal place. Okay, so in this case, it's $49.99. Why do people list their price like this anyway in real life?
Psychology.
Huh?
Psychology.
Psychology. What's the psychology trick?
it seemed cheaper than $50.
Yeah, once they see that 5 in the front, they think it's so expensive. But psychology wise, oh, it's in the 40s. Okay, and then of course they took away the penny, so then it is really 50. Okay, so that's all. I am actually wait. Um, okay, so for